Hi everyone. Today I'll be introducing an issue central to achieving global sustainability goals, that is the adoption of electric vehicles. Electric vehicles are rapidly gaining attention as a key solution to reducing carbon emissions and reduce climate change. Thus, governments around the world are actively promoting electric vehicles as part of their efforts to align with sustainable policies. Many of them offer incentives to accelerate electric vehicles adoption, such as tax breaks, subsidies, or free charging services. However, achieving these ambitious targets requires a deeper understanding of the key drivers of electric vehicle demand, such as fuel prices and income levels. Fuel prices can play a significant role in motivating consumers to switch from gasoline powered vehicles to electric vehicles. Similarly, higher income individuals may have a greater willingness to adopt electric vehicles due to their relatively high upfront costs. By identifying these trends, automotive companies can pinpoint high demand regions to focus their marketing efforts, while governments can develop targeted policies to further expand electric vehicles adoption. Our project wishes to identify how food prices and income levels will influence electric vehicle sales, with the goal of providing insights that benefit both businesses and policymakers.
Today, we focus on understanding the key factors driving electric vehicle, which is EV sales, and developing actionable strategies to promote adoption. For governments, we identify critical drivers such as fuel prices and income levels to design targeted incentives and regulations. And we align EV adoption strategies with sustainability goals like reducing carbon emissions. For EV companies, we pinpoint the regions with high sales potential based on income levels and fuel prices. We optimize marketing strategies and allocate resources efficiently to maximize impact. By addressing these objectives, we aim to accelerate EV adoption, benefiting both the environment and industry growth. This research empowers stakeholders to make data-driven decisions, fostering a sustainable future.
So our study focuses on the key problem statement that fuel price and income levels affect the sales of EV. So let me break this down. Fuel price is a potential game changer when it comes to consumer behavior. So when the cost of gasoline rises, the appeal of switching to EV becomes stronger thanks to their lower operating costs. But this is only part of the story. Income level can also play a significant role. So as mentioned earlier, while EV can save money in the long run, their higher upfront costs may deter adoption, particularly in areas with lower average incomes. So understanding how these two factors, fuel price and income, interact is essential for identifying the primary drivers of EV sales. So now, what is the relevance to Singapore? So in line with Singapore's Green Plan 2030, this project also evaluates the potential environmental impact of increased EV adoption. So Singapore aims to significantly reduce carbon emission through initiatives such as phasing out internal combustion engine vehicles and also building an intensive EV charging network. So by analyzing the relationship between fuel price, income level, and EV sales, we can then provide actionable insights to support these goals, such as optimizing incentive structures or identifying target demographic for EV promotion. So in essence, this project will not only address the important economic and behavioral question, but also contribute to Singapore's sustainability roadmap. Next, my groupmate will walk you through a statistical analysis of our problem statement.
Hello everyone, I'm Frederick, and I'll bring us through our hypothesis testing for our project. We wanted to assess the influence of fuel prices, income levels on the EV sales, which then leads us to form our null hypothesis, where there is no difference in the mean EV sales between the states with low and high fuel prices and those with low and high income levels, which then leads us to form our alternative hypothesis H1, where there is a significant difference in the mean EV sales between the states with low and high fuel prices and income levels. This is the dataset of all the US cities generated with the help of AI that showcase the various factors that we wish to test in our case, being the fuel price, income per capita, and the EV sales in all these states across 2023. With these large amounts of data, we are able then to use a two sample t-test for both factors to then help us compare the mean EV sales across the states. To analyze this dataset, we can perform our first t-test for the fuel prices using this dataset generated by uploading it in R firstly. We then define the median of the dataset before defining the high fuel groups to be states with fuel prices above the median and states with fuel prices below the median, to then assess whether fuel price significantly influence EV sales. By then performing this t-test in R, we attain a p-value of 0.001617, which is significantly lower than the significance level of 5%, in which we are conducting this test at. Hence, for fuel prices, we can then reject H0 or null hypothesis, in which we can then conclude that there is in fact a significant difference in EV sales between cities with high and low fuel prices. Using the same method as seen in the previous slide, now we can apply it to the column income per capita across all the US states. With same thing, we start off by defining the median point of the income column. Then, by defining what is high and low income per capita by relating them to the median. The high being the states having income levels above the median and vice versa. By then using t-test of the two datasets that we now have defined, we get a p-value for this test, which is 1.345 times 10 to the power of negative 8, which is significantly lesser than the 5% significance level as well. Hence, at this significance level, we can reject H0, our null hypothesis as well. That can conclude that there is in fact a significant difference in EV sales between high and low income per capita in states as well. Last but not least, I'll bring us through our conclusion for this hypothesis test. We concluded that the t-test for both the fuel prices and income per capita across the states in relation to EV sales gave p-values that were significantly less than 0.05 at the 5% significance level. Hence, we see that both factors caused us to reject our null hypothesis H0, which means there is a significant difference in EV sales when you see these with high and low fuel prices and income per capita as well. Thank you.
Hi, I'm Kevin, and I'll be presenting on the multiple linear regression model for EV sales in the US. So the equation is as such, where the dependent variable is the EV sales, and the independent variables are the income and fuel price. So previously, we concluded that income and fuel price both do affect EV sales. So this time, we'll be taking both of them into account and seeing if there are any changes or if any one of them is statistically significant. So this is the data set we'll be using imported into RStudio. So the EV rate in this case is basically referring to the rate of adoption of electronic vehicles, which is basically the number of registered electronic vehicles divided by the population for that state. And then we just make use of the summary and linear model command to give us our results. So from here, you can see that both fuel prices and income are actually statistically significant in contributing to EV sales, with both of their p-values being very close to zero. So you can see that fuel prices have a p-value of 1.2 times 10 to the power of negative 6, and income has a p-value of 0.003. So to conclude, we can see that both fuel prices and income levels are significant factors in driving sales of electronic vehicles in the US. Thank you.
Well, our research reveals the important insight into how fuel prices and income level affect the EV sales. Through the hypothesis testing, we confirmed that cities with higher fuel prices have higher EV sales than those with lower fuel prices. This finding emphasizes the importance of fuel price as a key motivator for EV adoption and encourage further research into policies that could emphasize this effect, such as the fuel taxes or EV subsidies. Furthermore, the multiple linear regression analysis reveals that both the income level and fuel price are strong predictor of EV adoption rates. High-income regions, in particular, are more likely to adopt the EVs, most likely due to the lower upfront costs. This suggests that manufacturers and policymakers should focus marketing and incentives in wealthier areas, while also looking into the financing options to make EVs more affordable in low-income areas. The findings has important implications for stakeholders. For governments, the findings highlight opportunity to combine EV incentives with fuel pricing strategies to accelerate carbon emission reductions. Businesses use the data to prioritize high-demand regions, optimizing marketing and resource allocation. Finally, understanding this driver enables us to develop data-driven strategies for increasing EV adoptions, which benefits both the environment and the industry. Thank you.